Think about the tech we use every single day. If you tried explaining, like, a smartphone or instant video calls or even just a pill for a toothache to someone from, say, the medieval period.
Oh, absolutely. It would just sound like pure sorcery, utter magic.
Right, and it makes you think what stuff feels like total magic to us right now might just be, well, completely normal for people maybe 100 years down the line.
And if you're listing things that feel like magic today, I bet teleportation is way up there for most people.
Definitely. Just vanishing from one spot and appearing somewhere else instantly. No travel time.
Exactly, that classic sci-fi idea.
So for this deep dive, we've got this stack of source material here, and we're going to really dig into what scientists actually mean when they talk about teleportation.
Yeah, trying to sift through the sci-fi versus the actual science.
Precisely. We want to explore the research. Some of it sounds pretty wild, maybe even a bit mind-bending, and see where things really stand today. Get our heads around the real physics involved.
Okay, let's do it. And maybe the first thing to clear up, based on these sources, is that when scientists talk teleportation now, they're usually, well, they're not talking about beam me up, Scotty.
Okay, so not disintegrating people and reassembling them across space.
Not currently, no.
Uh-huh.
The science is different, but honestly, it's just as fascinating in its own way.
All right, so let's dive into the first big idea the material covers. Space-time vacuum teleportation. That sounds weighty, very physics heavy.
It is. It's grounded deep in Einstein's theory of relativity. Before him, the picture was pretty simple. Space and time were just there,
Yeah.
fixed, like a stage.
Yeah, like a big, unchanging backdrop for everything happening in the universe. Time just ticked along the same for everyone, everywhere.
Exactly, a static stage. But Einstein, well, he turned that on its head. He showed that space-time isn't static at all. It's more like a flexible fabric. Think of a trampoline, maybe.
Oh, okay, trampoline.
Yeah.
And things with mass, like planets and stars.
They bend it. They warp that fabric. And that warping, that curvature, that's what we feel as gravity.
So my experience of space, and even time, isn't absolute. It depends on where I am on this trampoline and how I'm moving.
That's the core idea of relativity, yeah. Everything's relative,
Yeah.
except for one thing.
Ah, right, the speed of light?
Yeah.
That's always constant no matter what.
Exactly. That's the universe's speed limit, constant for everyone.
And this idea of space-time being flexible, this fabric, the sources mention this core principle that comes from it. Matter tells space-time how to curve.
And space-time tells matter how to move.
Yes.
It's this constant interplay.
And that implies, theoretically at least, that if you could somehow mess with the space-time fabric itself,
You could potentially influence how things move through it. Maybe even, take shortcuts.
like the rubber sheet analogy, put a bowling ball on it and a marble rolling nearby just has to follow the curve the bowling ball makes.
Precisely. It's following the geometry of space-time created by the mass.
Yeah.
Einstein's field equations, they mathematically describe exactly that interaction.
Okay, so if space-time can be curved and potentially manipulated, that leads us straight to wormholes, right? The ultimate sci-fi shortcut.
That's the theoretical link. Wormholes are basically hypothetical tunnels through this space-time fabric, a bridge connecting two potentially very distant points.
So you could, in theory, teleport by just hopping through the wormhole instead of traveling a long way around.
That's the concept behind space-time teleportation, yes.
Yeah.
But here's the massive but. The sources are very clear on this challenge.
Okay, what's the catch?
Keeping a wormhole open and stable, even a tiny one, say just a meter across, it would require a truly mind-boggling amount of something called negative energy.
Negative energy. Okay, now that really sounds like science fiction.
It sounds wild, but it's a legitimate concept in physics.
Hmm.
It's basically energy with, well, negative pressure or a negative mass equivalent, and the amount needed. The sources say you'd need the negative equivalent of more than 10 times the mass of Jupiter.
Wait, hang on. Negative mass. 10
Yeah.
Jupiters. Just to hold open a 1-meter tunnel? I can't even picture that scale. How does that compare to, like, anything we actually deal with?
It's completely off the charts. Think about all the energy humans use globally in a year. That's an utterly minuscule fraction of the positive energy equivalent of Jupiter's mass. Needing 10 times that in negative form, it's just astronomically huge, far beyond anything we can currently conceive of producing or controlling.
Wow. Okay, so a pretty significant hurdle then.
Understatement of the century.
But didn't the sources mention some lab work that scientists have actually created tiny bits of negative energy, something about the Casimir effect.
Yes, they have, and that's actually really important. It shows the underlying physics isn't, like, completely impossible.
Hmm.
The Casimir effect, for instance, involves placing two conducting plates incredibly close together in a vacuum,
Uh,
and the quantum fluctuations between the plates are suppressed compared to outside, creating a region with slightly lower energy density effectively, a tiny amount of negative energy pressure pulling the plates together.
so it can exist. The physics allows it in these very specific, tiny scenarios.
Exactly. There are other methods, too, involving things like accelerating mirrors or complex laser setups. They've demonstrated the principle, but scaling that up.
Scaling that up from lab bench scales to 10 Jupiters worth.
Okay.
Yeah, okay.
Right. So the conclusion from the sources on this path, the theory is fascinating. Wormholes are theoretically possible. Negative energy is needed. But the sheer amount required makes space-time vacuum teleportation highly improbable anytime soon. It's firmly in the realm of theory.
Okay, so that's one major avenue hitting a massive energy roadblock. Let's shift gears then. The sources talk about a second type, and they call this one the real deal, quantum teleportation. This sounds more promising because
Yeah.
it's actually happening.
It is. This is where things get really exciting, moving from space-time theory to actual experimental results. For example, Chinese scientists had a huge breakthrough a few years back. They successfully teleported a quantum state from a ground station all the way up to a satellite orbiting Earth.
Whoa, okay, hold on. Teleporting a state. What does that mean? Not like sending an actual particle.
Exactly. It's not about moving matter from A to B. It's about transferring information specifically. The precise quantum state, the properties, of one particle onto another particle somewhere else.
Okay.
How? The magic ingredient, if you will, is a phenomenon called quantum entanglement.
Ah, entanglement. Einstein's spooky action at a distance. The weird linked particle thing.
That's the one. It is spooky. When you entangle two or more particles, they become linked in this incredibly deep way. Their fates are intertwined no matter how far apart you separate them.
So measuring something about one particle instantly tells you something about the other one, even if it's light years away.
Instantly influences it, yes. Think of the classic analogy, the magic gloves. You have a pair, one red, one blue, put them in separate boxes, send one across the galaxy.
Right. The moment I open my box and see the red glove, I know instantly, faster than light could travel, that the other box must contain the blue one.
That analogy captures the correlation perfectly. But quantum mechanics adds another layer of weirdness. It's not quite like the gloves were red and blue all along, hidden in the boxes. It's more like the gloves don't decide their color until you look. The act of you observing your glove forces it into a definite state, red, say, and that act instantaneously forces the other glove, wherever it is, to become blue.
So the state isn't determined until it's measured, and measuring one fixes both.
Pretty much. Until you measure, they exist in a kind of fuzzy state of potentially red, potentially blue. Measurement collapses that potential into reality for both, instantly, across any distance.
Okay, that is spooky. And that instantaneous link. Scientists are using that to send information.
That's the essence of quantum teleportation. You take an unknown quantum state you want to teleport, say, from particle C. You interact particle C with one particle of an entangled pair, particle A. Then you measure something about C and A together. That measurement destroys the original state of C, but because A is entangled with particle B, which could be miles away, the information needed to reconstruct C's original state is effectively transferred to particle B. You just need to send some classical information, the results of your measurement on A and C, over a normal channel to the location of B.
So you use the entanglement for the instant link, but you still need to send some regular data, like over the internet, to finish the process.
Exactly. You're not sending the particle itself, you're teleporting its state. It's quantum information, using entanglement as a resource, plus that bit of classical communication.
Got it. Okay. So let's try and pull this together. We have the space-time manipulation idea, wormholes, negative energy, theoretically amazing, but facing this, well, almost comically large energy problem.
Right. Seems stuck in theory for now.
And then we have quantum teleportation. It's real, experiments are proving it, satellites are involved, but it's about teleporting information, the quantum state, not physical objects or people.
That's a really good summary of where the sources paint the picture. It's a super active field, blending deep theoretical physics with some really cutting-edge quantum experiments.
So why should we care about this now? I mean, it's fascinating, but it's not like I'm quantum teleporting my groceries home yet.
Well, a couple of reasons. First, just understanding this stuff pushes our knowledge of how the universe fundamentally works. What is space-time? What is information? What are the limits? That's intrinsically valuable.
True, expanding the boundaries of knowledge.
And second, even if we're not teleporting objects anytime soon, quantum teleportation of information is a cornerstone for future tech that will likely impact us. Think ultra-secure communication networks based on quantum principles or powerful quantum computers. This research is building those foundations.
Okay, so it has practical implications, even if it's not the sci-fi dream immediately.
Definitely. And looking way, way down the road, those sorts kind of hint at this?
Who knows? You mean maybe one day.
Maybe. Scientific progress is weird. Fundamental research into seemingly esoteric things like entanglement or space-time geometry could, maybe generations from now, unlock something completely unexpected. Maybe some form of teleportation becomes as normal for our great-great-grandkids as hopping in a car is for us.
Making our current tech look as quaint as horse-drawn carriages look to us now.
Exactly. It just shows how magic is often just science we don't understand yet.
Hmm.
Pursuing these fundamental questions is how we eventually turn magic into engineering.
It's a powerful thought. Which leads us to a final idea to leave people with, drawing from that quantum weirdness.
Yeah, that entanglement aspect.
If measuring a particle here can instantly influence its entangled twin clear across the galaxy, what does that really tell us about connection itself? About how information propagates, or maybe doesn't need to propagate in the ways we think, about the fundamental nature of reality.
Right. Does distance even mean the same thing at that level? It
Yeah.
really challenges our basic intuitions about space, time, and separation.
Something deep to ponder about the interconnectedness of everything.